Hi friends, let's detect segments in images using Meta's SAM2. We are going to do positive prompting as well as negative prompting using point coordinates and rectangular boxes. So the prompting, it looks like this. We can specify which part of the image we want to segment. For example, here we are trying to segment these two coordinates. So these bags have been detected as part of that segment. Okay. All right. So in a previous video, we set it up and detected the default segments. Today we focus more on the prompting. All right. So just download the repo, cd to the repo, and do the installations. And after the installation, we need to download the model checkpoints. So the checkpoints folder, it already has this download script. It simply download the 4 checkpoints related to different model size. For example, here we have the tiny one, which is 148 MB. And similarly, we have the small, base plus, and the large model, okay, 856 MB. So download all those models to the checkpoints folder, okay. All right. And then, okay, Torch and a bunch of helper libraries like matplotlib, numpy, and from SAM2, the main functionality is this SAM2 image predictor. Okay, and here we are setting the GPU. So it requires GPU. So I'm running on Google Colab. So T4 GPU. Okay. All right. So a couple of helper functions. So this function mask, it takes the output of the detection. So this mask is the output of the detection, which is a matrix of size equal to the input image. Okay. And this contains the binary values, ones and zeros, indicating where the detected mask is. Okay. So it takes the matplotlib access, which has the existing image or our input image, and it simply plot the mask in a different color. Okay, so this piece of code, it's quite straightforward, but if you have if anything is not clear, let me know in the comments. Okay, so we just take this mask and plot it on top of the image using different colors. Okay, all right. And then another helper function, show points. So this is for showing the positive and negative prompts. Okay, so positive prompts we show using 1, negative ones using 0. Okay, so the positive ones we display using this green, the negative ones using this red color. Okay, the prompting we can do not just using the point coordinates, but also using a rectangular box. Okay, so if we use a rectangular box, this is a helper function to show the rectangle on top of the image. Okay, this is another one, show masks. So when we want to show multiple masks, we use this function, which simply loop over the masks. Okay, so as you can see here, we are calling the show mask function, which we define here. Okay, so it just show multiple masks. All right, so using the same example code and images, so here we are loading an image of a truck, and this is how our image looks like. Okay, now, and we will be using this large model. So this is our checkpoint, and model config, this is already in the folder, so we don't need to do anything, and just initialize this SAM2 model, and then we initialize the predictor using the model. Okay, once we have the model, it's quite straightforward. So first, let's do positive prompting. Prompting is specifying a point in the image or the region of interest through a point coordinate or a rectangle box. So here what we have done is, so in this image, we have specified a coordinate 500 and 375. Okay, so it's on x-axis 500 and y-axis 375. So this is the point coordinate we have specified, and the label is 1, meaning it's a positive prompt. Okay, it's similar to how we generate images through text prompt, right? So in the prompt we can specify what we want to see in the image, as well as what do we don't want to see in the image. Okay, for example, hey, create a scenery with blue sky, something, so on and so forth. And in the negative prompt we can include, do not include any stars. Okay, so in a similar way, so this is our positive prompt, meaning we want to detect segments which encompass this point. Okay, so label is 1. All right, just show the image, and then all we need to do is just call this predictor function. So we specify the input points or the rectangle, and then the label positive or negative. Okay, so by default it return 3 detections or 3 segments. Okay, so here we are just sorting them based on their score, and this is how the output look like. So the masks, so these 3 represent the 3 detections, and 1200 by 1800, that's exactly the size of our image. Okay, so 1200 by 1800. As I mentioned, the mask simply contains the binary values 0s and 1s, 1s indicating where the mask is, 0s indicating non-mask area. Okay, so we simply call show masks function. So this is our original image, and then the masks along with the scores. Okay, and we also specify these the positive prompts, the negative prompts, etc. Okay, so as you can see here, we have the green star indicating this is our positive prompt, and then the first detection is in this blue color. Okay, so this is a detection with score of 0.4, and then we have the second detection, score almost similar, but this time, so here we have this window, it's a 2 glass windows. Here only this part is detected as the segment, and finally the whole truck is detected as the segment. But as you can see, the confidence score is much lower compared to the rest, because this has multiple segments. Okay, all right, and then in order to have more confident, we can specify multiple prompts, right, or multiple coordinates. If you specify only one, there is always an ambiguity to what hierarchy level we call it a segment, right? For example, let's say I specified a point on this rim. Now, should this segment be the whole tire including the rim, or just the rim itself? Okay, so by specifying additional coordinates, we can remove that ambiguity. Okay, we can make it easier for the model what segment we are interested in. Okay, so here the same point as before, and now we are specifying an additional point with label 1, meaning this is also a positive prompt. Okay, and call the same predict function, and this time we have specified we want to detect only one segment. Okay, all right, so here we have only one segment. Since we specified this point and this point, so those both points to be part of the same segment, part of the segment, right? So the only way these 2 points can be part of a segment is through the whole truck being detected as one segment. Okay, for example, let's say we have chosen maybe this point and maybe this point, these 2 points, then our detection could have been only these 2 windows. Okay, so you can play around these multiple points to narrow down or to broaden what you define as your segment. Okay, and now let's see a negative prompt. Now we don't want the whole truck to be detected as segment, but we want only this window part. Okay, so what we can do is we have the same 2 coordinates, but for the second coordinate we specify the label as 0, meaning, hey, in detect a segment which exclude this point. Okay, which exclude this point. All right, okay, it's the same standard procedure. Now as you can see, this time only this part is detected as the segment. So because here we have the positive prompt and this point is part of the negative prompt. Okay. All right. So the prompting, and not only through coordinates, we can even specify the rectangular boxes. Okay. So here we have a rectangle box, and then yeah, it's the same predict function. So we specify this rectangle box, and this car, a tire, is detected as a segment. Okay. All right. We can combine the rectangles and the points. So here we have a rectangle, here we have a point, but this time this point, it's a negative prompt because the label is 0. Okay. So what if we want to detect, let's say, only the rim as our segment? Okay. We are not interested in this tire. Okay. So when we specify this rectangle, both the tire and rim are detected as the segment, right? Now we want to exclude the tire. So what we can do is we can simply do a negative prompt by specifying a point on the rim so that only the tire is being detected. Okay, so that's what we are doing here. So we have added an additional prompt, a negative prompt, and this time, so within this box, excluding this point, the segment is this tire. Okay. All right. We can do batched one as well because any real world application, we will be dealing with multiple images. So here we have 4 rectangles. Okay. So our 4 input rectangles are one here, the second one, third one, and the fourth one. For each rectangle, you can see the detected segment. So for this one, the purple one looking correct. For this one, here is the one, and for this one, another tire. And when we have this large rectangle box, the whole truck is detected as one segment. Okay. And here is another example where we combine multiple images, or we run multiple images as a batch. Okay. So image 1, 4 rectangles, another image 2, which is this another truck with some groceries. So we have again some 4 coordinates. Okay. All are positive, and run the same function. And this is how it looks like. Okay. That we just saw. So here is the second image. We have chosen these 4 rectangles, and as you can see, within each rectangle, this bag is detected as a segment very accurately. Okay. What's this one? Yeah, and just similar to how we did the rectangle, we can even do it using points also. So for the first truck image, we have 2 points, positive. And for the second image with groceries, again, we have 2 coordinates, and both are positive. Okay. All right, exactly the same syntax. So for this one, this time we have chosen this coordinate and this coordinate as positive prompts. So only the bags containing those points are detected as the segments. Okay. Now we can apply similar logic to detect or track segments or objects within videos also. So we take the video, we break it into images or frames, and for the first frame, we specify the prompts, and then the segments are detected for the first image, and those segments are tracked for the rest of the frames or for the rest of the video. Okay, that's all for this video. And again, we could not go into much details into the code, but it's just 3 or 4 helper functions, and then simply specifying the prompt in the form of coordinate or rectangle, and the label positive or negative, and just invoking this predictive function, and then calling the helper function to show our detections. Thank you very much.